Assalamualaikum and good morning. My name is Muhammad Afiq bin Abdul Manan from DKM 5A. Manometric is 01 DKM 21F 2006. Our topic today is gas turbine power plant. For the introduction, in addition to change the technology environment, innovation in gas turbine power plant are also having a significant emotional and perceptual impact on people involved. A variety of positive effects reactions are simulated by this improvement through increased operational efficiency, safety and dependability, environmental sustainability, and economic rewards. Stakeholders feel more secure, confident, proud, and optimistic from engineer and operator to local communities. Comprehending the evident correlation between technology advantage and its effective consequence is crucial in order to fully grasp the wider implication of this breakthrough within energy industry.
Hi, my name is Chloe Taweni from DKM 5A and my number matrix is 01 DKM 21F 2005. Today I would like to talk about the overview of twin spool gas turbine engine of power plants concept and realizing their effective impact. Firstly, revolutionary twin spool design. The gas turbine power plants boast a groundbreaking twin spool engine design, a marvel of engineering ingenuity. This dual spool configuration embodies a symphony of seraphic power where each spool works in harmony to deliver optimal performance. Secondly, symbiotic. The twin spool gas turbine as a dance of precision and synchronization like two partners in a ballet. Each spool complements the other's movement, ensuring seamless power delivery and efficiency. This symbiotic relationship is not just mechanical, it's a testament to human creativity and collaboration. Thirdly, heartbeat of innovations. The twin spool gas turbine isn't just a machine, it's the heartbeat of innovation. Its rhythmic transmission symbols the relentless pursuit of progress, pushing the boundaries of what's possible in power generation. With every rotation, it whispers the promise of a brighter and more suitable future. Fourth, energy efficiency. The energy efficiency fuels the accelerating pulse of energy coursing through the twin spool gas turbine. Its relentless pursuit of efficiency resonates with our innate desire to do more with less, to harness the power of nature in its pursuit from. This efficiency isn't just about numbers, and it's about maximizing the potential and minimizing the waste. Fifth, the environment empathy. Environmental empathy beyond its mechanical powers, the twin spool gas turbine embodies a profound sense of environmental empathy. Its efficient design reduces emissions and carbon footprint, offering a glimmer of hope in our fight against climate change. With each rotation, it whispers a promise to protect our planet from future generations. 6. Empowering communities. The twin spool gas turbine isn't just a machine hidden behind fences and walls. It's a beacon of empowerment for communities. It brings light to the darkest corners, powers industries, and fuels progress. Its presence inspires awe and gratitude, reminding us of the transformation powers of energy. 7. Reliance in adversity. In times of crisis, the twin spool gas turbine stands as a symbol of resilience. Its robust design and unwavering reliability ensure a steady supply of power. Even in the face of adversity, its reassuring presence amidst uncertainty, a beacon of stability in a rapid changing world. 8. Unwavering commitment. The twin spool gas turbine embodies an unwavering commitment to excellence. It's not just a machine, it's a testament to human potential and the power of collective ambitions. With every revolution, it reflects our beliefs in the boundless possibilities of technology and the human spirits.
Infectious impact on individual. First, emotional impact. Confidence and trust. Safety and reliability. Development that make gas turbines safer and more reliability like better material and sophisticated monitor system inspire confidence and faith in engineering and operator. Peace of mind. By lowering worry about possible mishap of environmental danger, improve safety procedure and technology give local community and plant employee peace of mind. Second, pride and certification. Environmental sustainability. Technology that enhance fuel economy and lower emission are in line with the world sustainability objective. Cutting edge technology. Using modern equipment make working with enjoyable and proud for employees who may also feel more engaged and appreciate. Social impact. First, community relationship. Positive public perception. The plant reputation in the community is improved by innovation that lower pollutes and increase safety. Community engagement. Through the creation of jobs, the building of infrastructure, and the finance of social program by the plant's success, the economic benefits of innovation can result in a greater level of community engagement. Second, workforce development. Enhancement of skill. Ongoing trend and development in new technology broaden the skill set of the workforce, which promotes job certification and open up prospects for professional investment. Empowerment. By offering real-time data analysis and exchange, the human-machine interface innovation enable operator to have more control and comprehension over their operation. Economic impacts. First, job creation and security. Employment opportunity. New job in supporting industry as well as within the plant may be created as a result of technology development. Job security. Increase productivity and dependability, lower operating expense, and boost profitability, which give worker more job security. Second, fairness benefits. Cost saving, increased productivity and decreased downtime result in innovation cost saving that can be utilized to fund new invention and change working condition and benefit for employee. Economic prosperity. The power plant expansion and financial stability may have beneficial not on in fact on the neighborhood business and service. For this slide, I will share real-world examples that invoke emotional response related to gas turbine power plant investments. Reduction of carbon emissions. The name of the company is Siemens H-class turbine. Emotional response is hope and relief. One significant step in lowering carbon emission has been the creation of the H-class gas turbine by Siemens. This gas turbine is among the most efficient of the market with combined operation efficiency of over 60% because it widespread use in power plant. The carbon footprint of producing energy has been greatly decreased, aiding in fight against climate change and rising hope for more sustainable future. Second, economic growth and job creation. Expansion of gas turbine manufacturing facility in Charlotte, North Carolina. Emotional response is pride and optimism. Siemens increase the number of jobs in Crete and stimulate the local economy in Charlotte by expanding its gas turbine manufacturing plant. The community is proud of this development since it established the area as a leader in high-tech manufacturing and fosters stability and progress in the economy.
Hi, my name is Nur Kamila Tashamiti Maslan. My matrix number is 01DKM21F2012. Now we will discuss about societal implication for economic implication. National economic growth. Reliable energy supply is necessary for socio-economic stability and growth. Gas turbine power plants can help to ensure energy security, which is essential for industry operations, commercial organization, and overall economic development. Infrastructure development. The construction and operation of gas turbine facilities often result in larger infrastructure upgrades, such as improved transportation networks and public service that benefit society in its entirety. Next, environmental implication. For community impact, although communities could benefit from higher employment and economic activity, people are also impacted by environmental hazards such as polluted water, air pollution, and noise. Balancing all of this requires ensuring community involvement and implementing strong environmental standards. Climate change mitigation. Natural gas-fired power plants produce less carbon dioxide per unit of energy than coal and oil. This gives them a more reasonable choice in the fight against climate change, even though they are not as clean as renewable. Next is social implication, public health and safety. Gas turbines help to better air quality by emitting fewer pollutants than coal-fired plants, resulting in lower rates of respiratory and cardiovascular disease as well as improved overall public health. Educational development. Gas turbine power facilities require qualified workers to operate and maintain them. This encourages investment in education and training programs, improving the total skill level of the population. And lastly, long-term sustainability. Carbon capture and storage. By capturing and storing carbon dioxide emissions, investment in CCS technology seek to decrease the environmental effects of producing electricity from natural gas. Transition to cleaner energy. While gas turbines can help with the shift to cleaner energy, how they are linked with renewable energy sources and whether carbon capture and storage CCS technology are used will determine how sustainable they are in the long run. The positive emotional impact. For environmental justice, health benefits. Gas turbine creates fewer harmful emissions than coal-fired plants, which leads to improved air quality that also leads to fewer health issues such as respiratory and cardiovascular disease, increasing public well-being and reducing healthcare associated stress. Next, job creation, economic opportunities. The construction and maintenance of gas turbine power plants generate large number of works, which includes engineering and technical to support and service occupation. Individuals and their families may feel more economically secure and optimistic as the result of this employment improve. Next, energy access can improve quality of life. Access to reliable energy allows for the use of recent facilities and essential service, which improves overall quality of life. This can lead to increased satisfaction and happiness among communities. Negative emotional impacts. Environmental justice. Climate change concern. Despite being cleaner than coal, gas turbines still contribute to the release of greenhouse gases. Awareness of this might cause eco-anxiety and emotion of helplessness over climate change and its long-term consequences for the environment. For job creation, while gas turbines plants provide new jobs, they may also cause job losses in other energy industries, such as coal mining. This can lead to financial insecurity and emotional suffering for those affected. And lastly, energy access. Relying on a single energy source can cause anxiety regarding future energy security, particularly if there are fears about fuel supply disruption or price volatility.
Environmental consideration of gas turbine power plant. Firstly, reduce emissions. Gas turbine power plant typically produce fewer emissions compared to traditional fossil fuel plants, which can evoke a sense of relief and hopes for a cleaner environment. This reduction in pollution such as sulfur dioxide, nitrogen oxides, and particulate matter can lead to improved air quality, fostering a healthier ecosystem and a better quality of life for communities nearby. Secondly, mitigation of climate change. The use of gas turbines, especially in combined cycle plants, can contribute to mitigating climate change by emitting lower levels of greenhouse gases such as carbon dioxide per unit of electricity generated. This aspect can evoke feelings of responsibility and empowerment, knowing that the power plant is playing a role in addressing a global crisis. Thirdly, water conservation. Gas turbine power plants often require less water for cooling compared to traditional steam turbine plants, reducing the strain on local water resources and minimizing the impact on aquatic ecosystem. This conservation effort can elicit a sense of stewardship and reverence for nature, recognizing the importance of preserving water for future generations and maintaining ecological balance. Fourth, noise pollution. While gas turbine power plants are generally quieter than other types of plants, they still produce some levels of noise during operation. This can evoke emotional response such as annoyances or fluences among nearby residents, impacting their quality of life and sense of tranquility. Ethical consideration may arise regarding the equitable distribution of environmental burdens and the needs of priorities community well-being. Fifth, the visual impact. The visual presence of a gas turbine power plant with its towering structures and industrial mechanical can evoke mixed emotions with communities, while some may view it as a symbol of progress and economic development. Others may experience feeling or instructions or disconnection from nature. Ethical consideration may revolve around the aesthetic of the landscape and the right of individuals to enjoy nature beauty without visual observations. 6. The habitat distribution. The gas turbine power plants, like any industrial infrastructures, can disrupt local habitats and wildlife corridors during construction and operation. This can elicit emotional response such as a sadness or concern for the well-being of affected species and ecosystems. Ethical considerations may arise regarding the preservation of biodiversity and the obligations to minimize ecological harms in the pursuit of energy production. Lastly, is the seventh, which is the waste management. The gas turbine power plant produce waste materials such as ash and water waste, which require proper management to prevent environmental contamination. Emotionally, this can evoke feelings of responsibility and accountability for ensuring safe disposable practice and mitigating potential risks to soil and water quality. Ethical consideration may focus on the principles of environmental justice and the fair distribution of environment burdens among communities.